Dear students, now let me do this problem. In the previous lecture, I have told that I will do the problem when we are asked to solve the problem and we are asked that the tension in each string and acceleration of each and individual block. Here we have to find out that the acceleration of each block and tension in the string. And in the previous example, by using the constant equation, I have derived this formula or this relation, that is a2 plus a3 plus 2a1 equals to 0. And I have told there that this is the first step to do these kinds of problem where we are asked to tension in the string as well as acceleration of each and every block. So now let me take that the tension in this string is T, and as this is the separated string, the tension will be T prime. Okay. Now the acceleration of this block, let me assume the acceleration of all the blocks in positive direction, because we take upward direction as positive and downward direction as negative. As we use the constant equation, so the relation with the direction is within this equation, that is a2 plus a3 plus 2a1 equals to 0. In this equation we have all the information about the relation between these accelerations as well as in magnitude and in direction also. So we have to take the acceleration in this system, all the acceleration of the block in positive direction, and here the positive direction is upward direction. So I will take all the acceleration in upward direction, that is a1, that is a2, and that is a3. If any one of these is positive or negative, I have first to take all the acceleration in the positive direction. Okay, but if due to the nature of the system, if any of the acceleration is in downward direction, that is in negative direction, then it will automatically take from this equation, this constant equation, and this is our equation 1, and we have derived this equation in the previous example. So we will use this result here. So now we have to use the Newton's equation of motion, and we have to draw the free body diagram of each and individual block, and we have to write down the Newton's equation. So when we talk about the mass m1, so what will be the free body diagram of m1? Here one force is m1g in the downward direction and another force is tension in the upward direction. So the acceleration is a1. So the equation of motion for this block will be T minus m1g is equals to m1a1. This will be our equation 1. Now if we talk about the mass of m2 and m3, then what will be the free body diagram? Here m2g is in the downward direction and m3g also in the downward direction, m3g, and acceleration we have taken in upward direction. So T prime minus m2g will be m2a2. So we have T prime minus m2g is equals to m2a2. Similarly, T prime minus m3g is equals to m3a3. So this is our equation 2. So this is 1, so this is 2, this is 3, and this is our equation 4. Now we have 4 equations in our hand, and there are 5 variables, that is 1, 2, 3, 4 and 5. Here there is 5 variables, but we have in our hand only 4 equations, so we cannot solve. So we need one more equation also, and that equation we will get from here, that this is t and here is t prime. So t will be nothing but 2t prime, as the acceleration of this system and this system is same. So in balancing condition, t will be 2t prime. So we will get another equation also, that is t is equals to 2t prime. This is our equation 5. Now we have 5 equations in our hand, and we have to determine the 5 variables. Okay, so we can easily do the problem by solving this equation. Now this is one method to solve these problems by using the constant equation, and when we use the constant equation, we have to mind that, or we have to remember it, that the direction of the acceleration, we actually do not predict anything. We cannot predict the direction of the acceleration also. When we want to use the constant equation, we need not predict the direction as well as the magnitude. We have to choose all the acceleration in a certain direction. That direction may be of positive direction or may be of negative direction. And we will set the equation of motion, we will solve, we will get the result. Okay, but this method of solving the problem is some complicated, is actually more complicated, because we have the 5 equations and we have to solve this 5 equations. The problem will be little lengthy, but we can reduce the calculation or the number of variables from this system by using our prediction again here. So if we want to solve this problem by our prediction, then what we have to do, we have to use the concept of relative acceleration. So in that method this problem can also be solved, and I will find you that how we can solve this problem again by the concept of relative acceleration, that is by our prediction. Okay, so in that case I will not take this as a1, a2 and a3. I try to find the relation between the acceleration, and here I will also take the direction also. Okay, so now let me take the acceleration of this block m1 is in the upward direction. It must be upward direction because this side is the heaviest side, so it will be in the upward direction, and this pulley will move downwards at acceleration a. But here these two mass m2 and m3 also moving like this if m3 is greater than m2. If m3 is greater than m2, then m3 will moving downwards and m2 will moving upwards. So the acceleration of m2, if the acceleration of m2 is a prime, m2 and m3 is a prime, when this system is absent, okay, the upward system is absent. If we talk about only this pulley and this mass m2 and m3, this will be moving like this will be upward and this will be downward. So this mass will move upward with the acceleration a prime, and this mass will moving downward with the acceleration a prime. This will be same if this system will not present here. But if we consider this direction a, then with respect to this a, the net acceleration of this m2 will be a minus a prime, because due to this acceleration the pulley will moving downwards with acceleration a, and this mass m2 will upward with acceleration a prime. So the net acceleration will be a minus a prime in that case, in the downward direction, because a is downward direction. Similarly here m3 will also be in this a prime is also in downward direction, then a will also be in downward direction. So here the net acceleration will be a prime plus a. So here both the masses will be moving, net movement will be downward. But if we talk about this pulley will moving downwards. So these systems are moving downwards due to this acceleration, and this acceleration is more than this a prime acceleration. So whole the system will be moving downwards. But when we talk about the individual acceleration of m2 and m3, when this system is not present, that will be a prime. So due to a prime, this will be upward, this will be downward. And with this a prime, when we combine this a, there will be relative acceleration, that will be a minus a prime, which is downward, because a is greater than a prime. Here a prime is upward, a is downward, so a minus a prime, and here is a plus a prime. And now if we want to solve the equation, then we are able to reduce one variable, because if we talk about this system, then here what will be the equation of motion? m1 t minus m1g, t minus, I have one more pen, t minus m1g, this is t minus m1g is equals to m1. This will be our equation 1. I will not take it this equation. This will be equation 1, t minus m1g equals to m1 a. And for this, now the system is moving downwards, so we will write the equation of motion in the downward direction. So m2g minus t prime, here actually we use our prediction, so as well as the magnitude we also take the direction. Okay, so m2g minus t prime equals to m2 into a minus a prime, equation 2, and here m3g minus t prime equals to m3 into a prime plus a. This is our equation 3. And here we have the 4 variable 1, 2, 3, 4, t prime and a prime, but we have only 3 equations, so we need one equation also, and that will get from here t equals to 2t prime. So t equals to 2t prime. This is our equation 4. So again we have 4 equation and 4 variable, and we can easily solve the problem. But on the previous case we had 5 variable and we had 5 equation. So one equation is more. When one equation is more, then the problem will be little lengthy, and here by using our prediction we can reduce the problem a little bit out. Okay, not much more, we cannot reduce much more, because this calculation will also be similar to that. Okay, now we can solve this problem easily. But the interesting thing is that now if we compare this equation with our prediction, then we will get the result. Now I like to show you how this equation will also be valid for this acceleration, and it is obvious, it should be valid. Okay, so now I will tell you, the problem is easy, you can do the solution. Okay, now here a2 plus a3 equals to 2a1, where a1 is the acceleration of this mass m1, a2 is this mass m2, and a3 is this mass m3. Now here we can write that this a1 is nothing but a. Okay, but a2, what is a2? This is a minus a prime, but this is only magnitude, direction will be negative, this is moving downward direction. And similarly if we talk about a3, then a3 is also downward direction, then it will be minus a prime plus a. And now if we substitute this value over here, we will get obviously the result. Okay, so a2 is nothing but minus a plus a prime, and then a3 is minus a prime minus a, and then a1 is 2a1, 2a. Okay, so here a cancel out, 2a and a prime cancel, that will be 0. So this equation which we can derive from the constant equation is same as which we have assumed here, or we have used our prediction here. Okay, thank you.